Welcome to the part 2 of this Python series. Begin with try to understand the special built-in variable called dash dash name dash dash. It is act like a switch. So when you execute the Python script, this built-in variable will get injected into the Python. So when you run the script from its directory, the value of this variable will be dash dash main. As you see here, if I execute the script from here, value will be main. Assume that you have another Python file, however, like that is not the primary file, and your primary file will make use of the another Python file, kind of a utility file, right? So in that sense, if you print dash dash name in your utility file, it will not say dash dash name. However, it will return the name of that particular file. In this case, let's assume that name of the file it's a shop.py, right? So in this case, if you print a dash dash name in your shop.py file called by the main.py file, then it will print shop. It will not print main, right? So the reason is that I said like this is act like a switch, right? So some script you want to execute only when the file it's the main file, right? It will, like when you execute the file as a supportive file, you don't want to execute a certain portion of the script. But when you execute the same file as a main file, you want to execute something different, right? So let's assume that it is not a utility file, right? So let's assume that you have a package which we will discuss in a moment. So let's assume that you have a package in which like there is a file called again shop, but then like this time around it is part of a package called a store. In this case, it is not going to return the name of the file, rather it is going to return package dot name of the file, right? It makes sense, right? Because like it is part of a package, so it is going to tell you what is the package it belongs to dot name of the file. So this variable will be very useful when you try to understand under what context the file is called, right? Whether the file is called as a main file or a supportive file or a package file. So you will get to know that, using which you can control the execution behavior of that particular file, right? So now let's assume that I have a main method, like some sort of a function, right? Call it as a main, and then like I want to execute this portion of this main function only when this file it's directly called, not necessarily called by a different file or part of a package, but only when this file it's the main file I want to execute a portion of this script, right? And the way you do it's like just say, hey, if the variable name has the value of main, then you call the main function. I hope you understand this, right? So with that, let's try to recap what we discussed in our previous video. Discuss about variables, data types, list, dictionary, function, procedure, loops. So in this video, we will quickly recap all of these and move forward. So in order to recap all of these, I wanted to build a real world kind of application so that you can easily understand. So this is what I want to build. I want to build a grocery store checkout system. So we will start the program, we will display a welcome message, and we will check if a store is open. Then we will ask the user to enter item. If item is in the inventory, we will add the item into the cart and we will loop through. User will be asked to provide another item. If the item provided item is not available in the inventory, we will say that the item is not available and we will loop again. Then user will be saying, hey, like I am done. In that case, we will come out of the loop and we will complete the checkout process, wherein we will calculate the total and we will apply a small discount. If a total is greater than $10, we will apply a 10% discount. Otherwise, we will skip the discount and we will finally show the summary to the user. That's what I want to build. It's a pretty simple application that I want to build, right? Let's introduce some variables here. I have a store name called Freshmart, and the uh, discount threshold $10. Discount rate it's 10 percentage. It's the store open. I say it's open. Then we print all of these information here. Introduce some list and dictionary. So dictionary, again, like a dictionary, we know it's a key value pair. So we will use dictionary for our inventory. So here I'm saying like apple will cost you $2.50, banana will cost you $1, milk, bread, all of these. So these are all the inventory that I have in my store. To begin with, the customer cart will be empty. So I will print all this information here. Then let's introduce some functions and procedures. We do know that function it's like it will take an input and it will return output, where in procedures it might take an input or it might not take an input and it will never return anything, right? So again, like in my previous video I mentioned that I'm not going to call a procedure as a procedure, I'm going to call everything as a function. So let me introduce some function here. So add item, it is going to take a item from the user input, and like it will check if the item is part of the inventory. If it is, then it will add the item into the cart. Remember, like we have a cart, empty cart, so we'll be adding that selected item into the cart. If a item is not available in the inventory, for instance if a user is asking for a soap which is not in the inventory, then we will say that item is not available. Then we will do a user will be doing a checkout process. In the checkout process we say, hey, like calculate the total. So if you see here, we are reading the items from the cart and the uh, do the summation, right? We will calculate the total price for that, and we'll pass the total to the discount here, where like we will say, hey, like a total greater than or equal to set threshold. Then we will apply a discount. Then after the discount, whatever the total comes in, we will print that information here. Find one more function called main. So this is unlike the other functions. This function, it's our main function. So when we call this function, this is what going to call the all other functions, right? So first it will say, hey, welcome to the store, and it checks whether the store is open. It is forward. I also discuss about dash dash name built-in variable. So what we are saying is that if this file is the main file, then call the main method. So let me run this one. So it is asking the user to provide the item, right? So say like I wanted to buy a milk, and I also wanted to buy a banana, right? I also wanted to buy soap, right? So sorry, it says the soap it's not available, but then like it added the milk and banana. So with that, like I'm done. So I say done. Now it calls the checkout method. So in the checkout method, it calculates the total and try to apply the discount, and finally it prints that. So with this application, what we have done is that we have used everything that we have discussed so far. We introduced the variable, we have used the list and dictionary, we have used the function, we have used the loop, and we have also used the special built-in variable. In my previous video, I mentioned that when you have your notebook ready, you can copy all your code, move it to the .py file so that you can use it, right? So let me go ahead and copy all these into the .py file, exactly like whatever we have in the notebook. I moved everything to the .py file. So now I have the .py file, right? It is exactly the same. Now with that, like let me go ahead and run the file in the terminal. Now it is asking me to provide the item milk, banana, soap, exactly the same thing, right? And then like I said that, so it prints the same thing. So that how do we create the Python file, right? It is not that you have to build everything in the .py file. So basically you can make use of the notebook and finally move everything to the .py file. Now with that, let me move forward and introduce the modules. Created this Python script for the grocery checkout system, where like we kept everything from variable definition to function definition to the main method, everything in the very same file. So is there any problem with this file? Not necessarily right now, right? Because like this is not a very complicated implementation. It has couple of functions and a main method, and we are just invoking the main method. But think of this way, like when you are keep on adding the functions, the script will become complicated. It will become something like this, right? A very big storage space. So likewise, your program will become one monolithic big program, and it will become very difficult to manage the program. So at the time we have to split the implementation into pieces, and that is why like we have the module. So think of this way, modules are a way to organize your code. So let's assume that you have a house, right? So in room, bedroom, kitchen and all those things, right? So modules are something similar to that. So instead of keeping everything in the very same file, you will have a different file for a different purposes. For instance, when you want to perform a math operation, you want to move all your math related code to the math file. When you want to perform a science related operations, then you want to move all your files to the science related file, right? Something of that sort. So by doing this way, it becomes little easy for us to understand the code, and then like you can very well reuse the code. So whenever there is a need, you can always make a call to the separate module that you created. We are leveraging the existing libraries, right? We will come back and discuss in a moment. Now let's understand that modules are a way to organize your code. Basically, like move the code from your main file to different files and make a call to these files whenever there is a need, right? So now let's do this way. We will create a math.py file, and we will add some functions, and we will import this into our main file, and we will call these functions, right? So let's define the uh, module here. So modules are nothing but a separate file, right? So I created a file called mymath.py, in which like I have two functions, addition and subtraction, and I wanted to make use of this module in my main file, right? So in the main file, what you see, from which file import what are the functions, as easy as that. From which file import, you are importing, star means everything. If you really want to import a specific function, you can just say the name of that particular function. In this case, I imported everything, and now I can use the addition and subtraction. If you see it clearly here, this file, this main file, do not have the addition and subtraction definition. So addition and subtraction, when we call addition and subtraction, it will know that these functions are defined in the mymath, and it will make use of that. I can execute this. It is just going to print the result, right? It is going to make a call to that mymath and execute the function and return the value, right? So we need to understand, when we do this way, Python, it is going to create .pyc file. So if you see here, I did not create this folder, created for me by Python itself. This is a Python cache where like all the compiled code will be stored. You really don't have to worry much about this, just to understand that, right? Whenever we have a Python file, like for instance, we created this file, right? And when we execute this file directly, it is not going to create a .pyc, which is nothing but Python compiled file, right? So it is not going to do that, because like this is the main file. So for the main files, it is not going to create the compiled version, but for the modules, it is going to create the compiled file. So if you just go here, you will see it created mymath.pyc file. Use of this pyc, right? Python can expedite the execution, right? So the modules are already compiled. You have the bytecode ready for the execution, and whenever you make a call, it is not going to recompile your module file. Rather, like it is going to make use of the existing bytecode and use it. That way, like the compilation time can be saved. That is the reason why the modules will generate .pyc file. I already mentioned that the .pyc file will not get created for your main file every time. Now we know what is module it's all about. Now let's try to understand the package. With module you will have a single Python file. For instance, you will have a math.py, science.py, or whatever is that, right? It should be fine as long as your program it's not necessarily too much complicated. But when you really build the enterprise grade application, modules might not be sufficient. So that is why like you have to create a package. For package, it's nothing but a folder. Underneath you can have the modules. So that way like you can clearly organize your code so that it can be used and understand better. So if you see this table, we can clearly understand the difference. So module, it's a single py file, but package, it will have multiple modules under a folder, right? So like we are talking about multiple folders here, like multiple modules here. Modules are good enough for a small use case, but then like when we talk about the large or enterprise scale application, package is the way to go. For instance, module will have a math.py file, but for package you will have a folder. Under a folder you will have your module file, right? So like think of this way, this is your whole package, your house is your whole package, this is one module, this is one module, likewise like you will have multiple modules. So if you put everything within that container, it's called a package. Let me try to create a package called calculator. If you see here, I created a folder. Again, like if you see here, package will have a folder. So we created a folder called calculator. Underneath we will have a math.py file, which is the same math.py file. We will also have ini.py file. I will come back in a moment to discuss about that. We already discussed about this PyCache. Let's see like how do we use this, right? This from the folder name dot file name and import whatever is that. So remember, like in the module we said from the file name import whatever is that. Here we are saying from folder name dot file name whatever is that. That is the only difference because it is under the directory right now. And that's it. Like we can just run it. Let's talk about ini.py file. Ini.py file, it's a special file. So when you create a package, when you want to initialize something, then you can keep your code in the ini.py file. The structure goes like this: the folder name, underneath you will have ini.py file and your module, right? So when you keep your ini.py file empty, which means that like there is nothing, like right now if you see here I have something in the ini.py file and it is commented. I remember like we discussed about multi-line comment, that is what I have used. So there is literally nothing in the ini.py file, in which case you have to import like this, like the directory name and the module name and import. But instead of doing that way, what I want to do is that in the ini.py file, if I say from the module import everything, which means that these functions are directly available at the package level. You really don't have to go into the module, but at the package level these are available, in which case you don't have to say from package name dot module name, because like these functions are exposed to the package at the package level. So all you can say is that from calculator import whatever is that. Here I'm just importing addition. You can put an asterisk to import everything, but that is the whole idea here. Like in the init you can expose whatever you want to expose, right, at the package level. Then that is available at the package level for the consumers. Now I can just use the function as it is. Packages are flexible enough. There are multiple ways you can use or build these packages. So you can also have a multiple package. If you see here, I have addition and subtraction. And if you see the overall structure, each package will share the same structure. So basically the folder, init and module, same init and module. And the way you use it, a specific package import everything, from another package import everything. So I can add and subtract, right? Let me run this. So again, like as this is the very first time, it is going to create this cache file for both the packages. Now we can execute the program. Now we can also create a sub package. So basically sub package, it's like you will have a package. If you see here, I have a package here. So in the package, I have a math.py file. If I just go here, it has addition and subtraction. And then like there is a sub package. So if I just go here, it has a multiplication. So basically like one level has two functions and then like another level has, one more function. So I have addition, subtraction and multiplication. Addition, subtraction part of a package, and subtraction it's part of a sub package. Now let's see how do we use it. It is as simple as that from the folder.file, right? So now when you talk about the file at the package level, you say folder and the file name. And if it is a part of a sub package, then you say folder, subfolder and the file name. As simple as that. Now let me run it. So it is again going to create this PyCache and the compilation and then execute. Now let's talk about the libraries. Now we know like what is module, what is package, right? However, like when you go to the enterprise, you will not be creating the packages specific to your application. There are quite a few packages are common across all the teams and everybody will be using it. So in order to do that, you have to create the libraries. Hence, you have to follow a pattern for logging. In that case, you will create a library for logging and publish it so that whoever wants to make use of this particular library can install the library and use it. Now let's see how do we build the library. So we will follow the same structure as the package. So if you see here, I have a simple math and like underneath I have a source. This is going to be my package. So in this package, like I have a calculator and like I also have a utils.py file just to demonstrate, right? So if you see here, this calculator py just adds two number, right? Just a typical module, right? And the like utils.py, it's the supportive method. So I wanted to use the supportive method, then in the module I can say like from the supportive class or supportive file I have to import and like use it. This is very similar to the module, right? So we are mixing package and modules together in the library. So the enterprise application, you are supposed to do a testing. So in which case, like we will create a folder called a test. If you look into the test folder, here we have a test underscore calculator.py. We are importing the unit test. I will come back and discuss about other unit test, but what we are doing here is that we are testing our calculator module. So we are now if you look into the ini.py file, it's empty as well as this is empty. However, at the package level, if you look into the ini.py file, here like we have initialized everything. So what we are saying is that from the src and calculator module, import the add function. Same from the utils, you have to import the supportive method. And then like with the help of this R list, we are exporting everything that we imported into this, right? So basically like add and validate, we are exporting. So if you do this way, then whoever it's going to be the user, they can simply say that from this particular library import whatever the function they are interested in. Without that, we know that they have to go to the library and package and module. So we don't want to do that, right? And that's why like we kept it like this. To convert the package to a library, you need to define the toml file. You see this configuration, it has quite a few sections. So first we will define the build system. So we will be using the setup tool to build the library. And then like under the project sections, we will define the project information like project name, version, description. To use the long description, you can use the readme file, Python version that you wanted to have, license, and then like classifier, dependencies and all those. And then like usually like you will also provide the link to your repository if it is an open source project. Then you will also define your dev environment dependencies, right? So once it is done, using which you can convert the package to the library. So let me show you how do we do that. We have to open a terminal. Let me open a terminal. Let me navigate to the folder, and then first of all we have to create a virtual environment. As of now we have used the base Python development purposes, but now we are going to create a virtual environment. So if you see here, as I executed this particular command Python dash m virtual environment, name of the virtual environment, if you see here, this gets created. If you see here, like there are quite a few packages that we have already. Why do we do that? So basically, like let's assume that when you have a multiple project, you don't want to mess up your base environment. Some project will be using different version number, like NumPy 3.3, but other projects may be using 3.3.3. So you don't want to mess up your base Python environment. So for each project, you will have your own virtual environment wherein like you can do the library installation. So now that we created the virtual environment, time to activate the virtual environment. So now we have to activate. So basically the command, it's the source, the virtual environment name bin activate. Okay, so if you see here, there is a bin, and then like there is some bash command that you need to execute. So now if you see here, from a base we are now into the virtual environment. So now we have to install quite a few libraries before we convert our package to the library, right? So there are quite a few packages that we need to install. So let me install some of these packages. So we have to install wheel. So now if you see here, like I have installed a wheel. Now before we convert this to the library, let's also run the test cases. So if you run the test cases, it is going to tell us that all the tests are passed. Now time to create a library. So we need to run this command python setup, and then we have to see source distribution, binary distribution. Run the command. So it is going to create a distribution for us. So if you minimize all of these, if you see here, there is a distribution created. So here we have a binary distribution and the source distribution. So we created the library, we can install our library. So to do so, just say a pip install dot. So it is going to install our library. So it is going to tell us that hey, this particular library got installed. If you see here, it says that this particular library got installed. So if you come over to the library section here, you will see your library, right? Use our library. So let me come out of this virtual environment. I have created a simple Python script. So it is just trying to use the library to we can run the Python script. So it is giving us the result. Finally, you can deactivate your virtual environment. Now we are back to the base Python environment. Let's move forward and try to understand how do we handle the files. We want to store the information permanently. We will be using files. For instance, let's assume that you have a dictionary and you wanted to save this information into the file so that whenever there is a need, you can retrieve this information, right? Access the file using this open method, where you will be passing the name of the file that you wanted to access and the mode. Here R means read. So we open the file and then we read the content and we print the content. So before I do that, let me open this file. It just says that this is your toy file, right? So I just read this information, I print this information. But as you see here, as I open the file, I have to close the file. If I do not close the file, then there is going to be resource leakage. To avoid that, we can use something called a context manager. So let's assume that you wanted to take something from your house and leave. So you will open the door, go inside, get whatever you wanted to have it, and then before you leave, you close it, right? Exactly, it's what the context manager does. So the way it works, it goes like this. So I have defined the enter method and the exit method, and there is going to be a function that I have as a part of this particular class. So the way you use the context manager, it with the with a keyword, right? So with you will be providing the context manager, call it as a message, and then like I'm calling the method say hello. It will do is that first it will invoke the enter method, and then like it is going to print enter in the context, and then like we are making a call to the say hello, so it is going to return that. Once we are done with the execution, it is going to say that existing the context. So we can use this context manager to work with the file, right? So now the way we work with the file with open file name, everything going to be same except that we are using this with keyword. So with we are using the context manager open, pausing the file name, mode, call it as a file, read the content, print the content. We really don't have to close the file by ourselves because like we are using the context manager. So here like we are writing the file. So what we are doing is that we are like we have opened the file with the write mode, and like we are writing file.write whatever the information that we wanted to write. Then we will print the file line by line. So we just open the file in a read mode, and then like read the individual lines and print the lines here. So we can also append the file. So what is the difference between write and append? Write means like whatever the existing content that we have in that file that will get lost, and whatever you are writing it will go into the file. But with append it is going to possess the existing content, and top of that it is going to write this information. Now if I write this information and if I try to print this value, now let me print this, it is going to like whatever this is what it already had, right? And then like it added this. So that is the difference between write and append. And then like now we will see like how do we read the file, like content of one particular file, and write it into another file. So simple, like we will open the file, read the content. Now we have the information in the content, and we open the destination file with the write mode, and then like write this information here. We will also see some additional operation with respect to the file. So if you see here, you wanted to get the current working directory. To do so, you can import the package OS, and then like using which you can get the current working directory. So if you just print that, it is just going to tell you like what is the current directory is. And if you wanted to create a new directory, you can very well do so. So if you see here, like I just created a package directory, and if you wanted to list the directories, you can use the list directory command. You see I have a folder name, file name. I wanted to join both, so you can do it using OS path join method. See here, I get the current working directory, I pass the folder directory name and the file name. I can print that complete path here. Also you can check if a file exists by using this method. So it is going to tell us whether the file exists or not exists. So based on which you can create a new file or append the existing file. And if you see this one, it says that the given path, it's a file or a directory. So of course this is going to be a file, right? So is file. So if it is a file, it is going to say it is file. If it is a directory, it is going to say this is a directory. So it is just going to say this is a file. Likewise, you can also get the absolute path. So you can just provide the relative path, and like you can get the absolute path in the sense like the complete path, right? So you can get the complete path as well. So these are all the operations that we can perform with respect to the file. So in the upcoming video, we will discuss the remaining modules for this particular video. Thank you for watching.